You're resting peacefully, perhaps feeling the soft weight of a cozy blanket, or the gentle, rhythmic motion of your own breathing. As the world outside begins to hush its busy sounds, a familiar sense of peace might settle gently over you, a quiet embrace of the darkness within your room. This darkness feels safe, doesn't it? It's a comforting veil, allowing your thoughts to gently drift, preparing you for slumber. But tonight, we'll softly consider another kind of darkness, a far vaster, more profound stillness in the distant cosmos, and gently ask, what profound secrets, what wondrous mysteries could possibly be hidden within the deepest, most enigmatic voids of our universe? We often associate darkness with absence, the absence of light, of sound, of form. But in the vast, swirling tapestry of the cosmos, darkness can be a profound presence, a silent crucible where the most astonishing phenomena reside. Far beyond the familiar twinkle of stars and the soft glow of distant galaxies, there exist regions where light itself seems to vanish, drawn into an unbreakable embrace. These are the whispers of cosmic night, realms of absolute quietude that hold some of the universe's most captivating, yet often misunderstood, secrets. Imagine, if you will, the gentle light from a distant star, patiently traveling across unimaginable distances, only to encounter a region where its luminous journey gently ceases. It doesn't crash, it doesn't shatter, it simply yields, drawn into an unseen, profound stillness. This isn't a wall or a barrier. It's a profound curvature in the very fabric of existence, a gentle, inescapable pull that captures everything, even light, within its silent grasp. This initial contemplation invites a deep sense of wonder, a quiet questioning of the universe's most extreme, yet serene, landscapes. The very idea of such a place invites a gentle curiosity. What kind of force could be so profound, so all-encompassing, that it could hold light itself captive? It's a concept that stretches the very edges of our gentle understanding, prompting us to softly reconsider the familiar laws of physics that govern our everyday world. These enigmatic regions are not empty voids to be feared, but rather exquisite examples of the universe's endless creativity, life blossoming in the most unexpected of places, finding its own gentle ways to thrive in the perpetual darkness, or in this case, defining the very essence of its most profound silence. Consider the immense silence that must reign within these cosmic abysses, far from the vibrant, tumultuous birth of stars or the gentle collision of galaxies. These deepest regions are realms of almost absolute stillness. They are broken only by the theoretical, subtle whisper of quantum fluctuations, or perhaps the faint, distant calls of space-time itself, speaking in frequencies far beyond our comprehension. This deep quietude is a testament to the immense, unhurried forces that shape our universe, a profound calm that invites you to release any lingering tensions and simply exist in the peaceful awareness of the moment, suspended in the cosmic dark. This initial journey into the concept of these profound cosmic shadows is not about confronting the terrifying, but about embracing the magnificent unknown. It's about understanding that even in the most seemingly extreme environments, the universe reveals its deepest truths, patiently adapting, quietly innovating, creating phenomena that fill us with serene wonder. The mystery of these dark realms is not a frightening void, but a profound canvas upon which the cosmos has painted some of its most exquisite and enduring masterpieces, waiting for our gentle contemplation. So, as you continue to relax, allow your mind to gently contemplate the familiar, comforting darkness of your room, and then, with a soft breath, imagine expanding that darkness, allowing it to gently swell into a vast, cosmic shadow. Feel the gentle embrace of this boundless stillness around you, the gradual fading of familiar stars, and the subtle shift towards a profound, ancient quietude. This quiet descent, this initial invitation into the deep cosmic night, is the perfect companion for your journey into rest. A soft reassurance that even in the greatest unknowns, there is a serene beauty waiting to be discovered, embracing you gently as you drift into the tranquil depths of slumber. Now, let's allow our minds to linger a little longer on this gentle invitation of cosmic darkness, this liminal space where the familiar cosmos begins to yield to the profound unknown. Imagine the countless stars, those brilliant beacons of light, scattered across the night sky like luminous dust. Each one burns with a fierce, radiant energy, sending its light waves cascading across unimaginable distances, carrying tales of its fiery birth and long, luminous life. But even these majestic sources of light cannot escape the subtle, yet relentless, pull of certain regions in space. This profound influence is exerted by objects that are so incredibly dense, so profoundly massive, that they warp the very fabric of reality around them. They are born from the gentle, inexorable collapse of colossal stars. Stars so grand that their final moments are a slow, inward sigh, a profound surrender to their own immense gravity. As these stars gracefully contract, their material is compressed beyond any familiar state, packing unimaginable amounts of mass into an incredibly small, silent sphere. And it is this extreme concentration of mass that creates the powerful, all-encompassing embrace that defines these enigmatic regions, the concept of a point of no return, where light itself becomes captive, might seem unsettling, like a final, unyielding boundary. But consider it not as a wall, but as a threshold, a gentle, one-way door to a realm of profound cosmic stillness. Here, the usual rules of the universe, the ones we so comfortably rely upon, begin to softly yield, giving way to a new, more profound set of principles. It's like stepping from a brightly lit, bustling garden into a vast, silent chamber where the very air thickens with mystery, and familiar sounds gentle into whispers. The profound silence that permeates these regions is unlike any silence we know on Earth. Here, there are no atmospheric disturbances to carry sound, no gentle breezes to rustle leaves, no familiar echoes bouncing off distant surfaces. Even the faintest cosmic rays or the most subtle quantum fluctuations are gently pulled into the profound stillness, creating a void that is truly, utterly quiet. This deep quietude is a testament to the immense, unhurried forces that shape our universe, a profound calm that invites you to release any lingering tensions and simply exist in the peaceful awareness of the moment, suspended in the cosmic dark. The allure of these regions lies not in their perceived danger, but in their profound mystery. They are cosmic laboratories, where the most extreme conditions imaginable quietly exist, pushing the very boundaries of our understanding of physics. Scientists, like patient weavers, are constantly trying to unravel the intricate threads of their existence, using the gentle hum of mathematics and the soft light of observation to glimpse the secrets held within their silent embrace. The questions they pose are profound, inviting us to contemplate the very nature of gravity, time, and the ultimate fate of matter itself, a general historical fact that highlights the quiet contemplation of these objects. The concept of objects so dense that light could not escape was first theoretically proposed centuries ago, long before any observational evidence. thinkers quietly pondered the implications of such extreme gravitational fields, creating a theoretical framework that later found gentle confirmation through the subtle observation of stellar movements and gravitational lensing, proving that the universe often reveals its deepest secrets through the softest whispers of mathematics. Here's a lesser-known detail about this initial contemplation. While the term black hole was coined much later, the idea of dark stars, or gravitationally collapsed objects, was explored as early as the late 18th century by Jean Michel and Pierre-Simon Laplace. They quietly wondered what would happen if a star were so massive and compact that its escape velocity exceeded the speed of light, pondering the profound implications without any knowledge of modern relativity. It's like a gentle, ancient seed of an idea, patiently waiting for the right conditions to sprout into full understanding. And for an ongoing academic debate, scientists are still actively researching the precise definition of the interior of these objects and whether information is truly lost when it crosses their boundaries. A profound concept known as the information paradox. How does the universe reconcile the apparent loss of information with the fundamental laws of quantum mechanics? This intricate interplay of theories remains a fascinating and complex area of study, revealing the subtle wisdom and profound challenges at the very edge of our cosmic understanding. So, as you continue to relax, allow your mind to gently contemplate the familiar, comforting darkness of your room, and then, with a soft breath, imagine expanding that darkness, allowing it to gently swell into a vast, cosmic shadow. Feel the gentle embrace of this boundless stillness around you, the gradual fading of familiar stars, and the subtle shift towards a profound, ancient quietude. This quiet descent, this initial invitation into the deep cosmic night, is the perfect companion for your journey into rest, a soft reassurance that even in the greatest unknowns, there is a serene beauty waiting to be discovered, embracing you gently as you drift into the tranquil depths of slumber. You're floating deeper now, gently carried by the quiet understanding of cosmic night and the subtle presence within profound shadows. As you drift, let's consider the very fabric of our universe, not as a rigid, unyielding structure, but as something far more fluid and wondrous. Imagine it as a vast, invisible tapestry, woven from the threads of space and time, a soft, cosmic cloth that can be gently persuaded to bend and curve. This is the serene essence of spacetime's quiet flow, how it gracefully yields to immense celestial bodies, hinting at a profound distortion that holds incredible secrets. For centuries, thinkers imagined space as an empty, unchanging stage upon which the universe's grand drama unfolded. Time was seen as a separate, relentless river, flowing independently, always at the same pace. But with the quiet brilliance of Albert Einstein, we began to gently understand a much more intricate and beautiful truth that space and time are not separate entities, but are inextricably woven together into a single, four-dimensional fabric called spacetime. Think of it as a vast, cosmic ocean, whose currents and depths are subtly influenced by everything within it. Now, this may sound a little strange, but let's gently consider how this cosmic fabric behaves. Imagine placing a large, heavy bowling ball onto a perfectly taut, flat rubber sheet. The bowling ball doesn't just sit there. Its weight causes the sheet to gently dip and curve around it. The heavier the ball, the deeper and more profound the curve. This simple analogy, though imperfect, offers a gentle glimpse into how massive objects in the universe interact with spacetime. In our cosmic tapestry, massive objects like stars and planets are like those heavy bowling balls. Their immense gravity isn't a mysterious force pulling things towards them across vast distances. No, instead, gravity is the direct consequence of how these massive objects gently curve or warp spacetime around themselves. When a smaller object, like a tiny comet or even a beam of light, approaches a massive star, it doesn't get pulled by an invisible string. Instead, it simply follows the natural curves and contours of the spacetime fabric that the star has created. It's like a marble gently rolling across the curved rubber sheet, its path dictated by the dip in the fabric rather than by an unseen force. This profound curvature in spacetime explains many wondrous phenomena in our universe. It explains why planets gracefully orbit stars, perpetually falling into the gentle curve created by the star's mass, never quite reaching it. It explains why light, which always travels in a straight line through space, appears to bend when it passes by a massive galaxy or a colossal cluster of stars. It's simply following the curves in spacetime that those massive objects have gently woven. It's like a peaceful stream, gently following the natural bends and twists of the landscape, its path guided by the contours of the Earth. The more massive an object, and the more compactly that mass is concentrated, the more profoundly it persuades spacetime to bend. A gentle planet like Earth creates a subtle dimple in spacetime. A mighty star creates a deeper, more significant well. But then, there are regions where mass is so incredibly concentrated, so profoundly dense, that it creates a curvature in spacetime so extreme, so deep, that nothing, not even light itself, can escape its gentle, inescapable embrace once it crosses a certain threshold. These are the enigmatic regions we are softly exploring tonight. This idea of spacetime as a fluid, responsive fabric, rather than a rigid stage, transforms our understanding of the universe. It tells us that space and time are not merely passive backdrops, but active participants in the cosmic dance, bending and flowing in response to the grand forces of gravity. And in the most extreme corners of the cosmos, where spacetime is bent into its most profound curves, lie some of the universe's most captivating secrets, patiently waiting to be glimpsed through the gentle whispers of mathematics and observation. A general historical fact that highlights this revolution in understanding before Einstein's theory of general relativity, gravity was understood as a force acting across distances, as described by Isaac Newton. Einstein's gentle revelation that gravity is, in fact, the curvature of spacetime itself, completely reshaped our understanding of the cosmos, making it a far more fluid and interconnected place than previously imagined. Here's a lesser-known detail about spacetime. While we perceive time as flowing uniformly, general relativity predicts that time actually passes more slowly in stronger gravitational fields. So, if you were to gently approach a massive star, your clock would subtly tick a tiny bit slower than a clock far away in weaker gravity. This phenomenon, known as gravitational time dilation, is a profound consequence of spacetime's curvature, a subtle whisper from the universe about the interconnectedness of space and time. It's like a gentle, unseen current, subtly altering the speed of a tiny boat as it enters a deeper, more profound pool. And for an ongoing academic debate, physicists are still actively researching the precise nature of spacetime at the very smallest scales, at the quantum level. Does spacetime remain smooth and continuous, or does it become foamy or granular? Reconciling the smooth, gentle curves of general relativity with the inherent discreteness of quantum mechanics remains one of the deepest and most beautiful puzzles in modern physics. It's a complex, beautiful puzzle, gently inviting us to understand the subtle wisdom of reality's most fundamental fabric. So, as you continue to drift, allow your mind to gently contemplate the vast, invisible tapestry of space-time, curving softly around the cosmic objects within it. Feel the profound peace that comes from understanding how massive celestial bodies gently persuade this fabric to bend, creating the very force of gravity. Let this understanding cradle your consciousness, like the serene, unwavering flow of space-time itself, as you gently surrender to the peaceful, restorative depths of slumber. The quiet hum of cosmic curvature, a testament to the universe's profound interconnectedness, is now your lullaby. A soft reassurance that wonder and mystery exist even in the familiar embrace of gravity. You're floating deeper now, gently carried by the quiet understanding of spacetime's subtle, wondrous flow. As you drift, let's turn our attention to the cosmic architects of these profound curvatures, the immense celestial bodies that, in their final moments, undergo a transformation so complete, so profound, that they create the deepest wells in the fabric of reality. Imagine a colossal, luminous star, having lived a long, brilliant life, now beginning a gentle, inexorable process of drawing inward, folding itself into an unimaginable stillness. This is the serene essence of when a star softly gathers itself, a quiet, graceful collapse that births the most enigmatic phenomena in our universe. Stars, those distant, shimmering jewels in the night sky, spend most of their long lives in a delicate balance. Inside their fiery cores, a gentle, continuous process called nuclear fusion is at work, patiently converting lighter elements into heavier ones, much like a cosmic oven gently baking new ingredients. This fusion releases an immense outward pressure, pushing against the star's own colossal gravity, creating a perfect, harmonious equilibrium. It's like a peaceful juggler, effortlessly balancing countless luminous balls, each one pushing outwards just enough to counteract the Earth's gentle pull. However, even the grandest stars, those magnificent celestial titans, eventually reach a quiet conclusion to their fusion. For stars that are particularly massive, many times larger than our own gentle sun, this end is not a fading whisper, but a profound, inward journey. Once their core runs out of the lighter elements to fuse, the outward pressure that has supported them for billions of years begins to subtly wane. And when this gentle pressure diminishes, the star's own immense gravity, that pervasive force that seeks to draw everything inward, finally wins its patient, silent tug of war. What follows is not an explosion in the way we might imagine, filled with chaotic noise and dramatic bursts of light. No, for these colossal stars, it's often a process of profound inward surrender, a graceful collapse that happens with astonishing speed, yet with a quietude that permeates the vastness of space. The star's core, once a furnace of creation, begins to rapidly, inexorably implode, drawing all of its immense mass inward into an incredibly tiny, dense point. It's like a colossal, billowing cloud, silently and swiftly gathering itself into an impossibly small, dense droplet. During this magnificent, inward collapse, the star's outer layers might briefly rebound, creating a luminous, transient spectacle known as a supernova. This burst of light, while visually stunning across the cosmos, is merely a fleeting echo of the profound internal event. The true magic, the creation of something truly extraordinary, is happening in the core, the gentle, relentless compression of matter to unimaginable densities. The atoms themselves are squeezed so tightly that their electrons are forced into their nuclei, combining with protons to form neutrons. This creates a hyperdense state known as a neutron star, a sphere perhaps only 12 miles across, yet containing more mass than our entire Sun. It's a profound transformation, a quiet folding of immense cosmic material into a miniature, dense marvel. But for the very largest stars, those that began their lives with truly colossal masses, even the formation of a neutron star isn't the final destination. The inward pull of gravity is so overwhelmingly immense that it continues to compress even the neutron star's incredible density. There is no force known that can withstand this final, inexorable squeeze. And so, the star's core continues to contract, relentlessly, infinitely, until all of its mass is concentrated into a point of unimaginable density, a region where space and time itself are profoundly warped. This is the tranquil, yet powerful, birth of a black hole, a cosmic entity born from the soft, complete surrender of a magnificent star. This process of stellar collapse and black hole formation is a deeply strange idea, yet also kind of beautiful. It reminds us that even in the most dramatic cosmic events, there is an underlying elegance, a profound adherence to the subtle laws of physics. The star doesn't fight its fate. It gently yields to the pervasive force of gravity, transforming its luminous existence into a silent, profound singularity, a gateway to the most enigmatic realms of our universe. A general historical fact that highlights the quiet contemplation of stellar lives for millennia. Stars were perceived as unchanging, eternal lights in the sky. The understanding of their life cycles, from fiery birth to gentle, eventual demise, and the concept of stellar collapse only emerged with the development of modern astrophysics and quantum mechanics in the 20th century, revealing a much more dynamic and intricate cosmic ballet. Here's a lesser-known detail about the quiet precision of stellar collapse. The amount of mass a star retains after its fusion ends is absolutely critical in determining its final fate. If it's less than about 1.4 times the mass of our Sun, a boundary known as the Chandrasekhar limit, it will quietly become a white dwarf. If it's between about 1.4 and 3 times the Sun's mass, it will gently form a neutron star. But beyond that, Oppenheimer-Volkoff limit of about 3 solar masses. The collapse continues inexorably to a black hole. It's like a cosmic scale, delicately balancing the star's final destiny. And for an ongoing academic debate, scientists are still actively researching the precise details of what happens in the very core of a collapsing star just before it forms a black hole. What are the exact conditions and reactions that lead to this final, ultimate compression of matter? The physics of these extreme environments remains a fascinating and complex area of study, revealing the subtle wisdom of matter's profound transformations under unimaginable pressure. So, as you continue to drift, allow your mind to gently contemplate the profound journey of a star, softly gathering itself into an unimaginable stillness. Feel the deep peace that comes from understanding this quiet, graceful collapse, transforming a luminous giant into the most enigmatic presence in the cosmos. Let this understanding cradle your consciousness, like the serene, unwavering embrace of cosmic gravity, as you gently surrender to the peaceful, restorative depths of slumber. The quiet birth of a black hole, from the soft surrender of a magnificent star, is now your lullaby. A soft reassurance that even in the most profound transformations, there is a beautiful, silent elegance to be found in the universe's grand design. You're floating deeper now, gently carried by the quiet understanding of a star's profound, graceful collapse. As you drift, let's consider the most enigmatic boundary in all the cosmos, a threshold where the very fabric of space-time bends so profoundly that light itself can no longer escape. Imagine not a rigid wall or a terrifying chasm, but a subtle, invisible veil, a serene, one-way passage that, once crossed, offers no return. This is the profound essence of the event horizon, a hidden, silent, cosmic boundary, a profound threshold beyond which all familiar paths gently dissolve into the unknown. For a long time, the concept of such an ultimate boundary was purely theoretical, a whispered implication of the gentle equations of physics. But with the patient advancement of astronomical observation and the delicate interpretation of subtle cosmic phenomena, the event horizon has emerged as a very real, albeit invisible, feature of our universe. It is the defining characteristic of a black hole, the luminous boundary that separates its profound interior from the rest of spacetime. Imagine a calm, still river, flowing gently. Now imagine a point in that river where the current begins to accelerate, subtly at first, then more rapidly, until eventually it becomes so swift that even if a small and determined boat were to row with all its might against the current, it could never make its way back upstream. The event horizon is precisely analogous to this point of no return in the river of spacetime. It is the boundary beyond which the escape velocity, the speed an object needs to travel to break free from the gravitational pull, exceeds the speed of light. The fastest speed known in the universe. This means that as you gently approach an event horizon, there is no physical barrier to perceive, no glowing line in the cosmic dust. It is entirely invisible, a profound mathematical surface. You would feel no sudden jolt, no immediate change in your experience as you cross it. For a fleeting moment, you might not even realize you have passed the point of no return. Yet, once you gently drift across this subtle threshold, the very path of light from within that boundary curves back towards the black hole's center, making it impossible for any information, any image, any signal to ever reach an outside observer. It's like stepping through a silent, one-way door into a room where all light gently fades and never reflects back, leaving no trace for those outside. The concept of light being trapped is profoundly beautiful. Light, the messenger that carries all information about the universe to our eyes, that allows us to perceive galaxies and stars, becomes captive. This is why these cosmic entities are called black holes, not because they are truly empty voids, but because they absorb all light, making them utterly invisible against the cosmic tapestry. Their presence is only revealed by their profound influence on the spacetime around them, by the gentle bending of light from distant stars, or the subtle dance of gas and dust spiraling into their silent embrace. Consider the profound silence that permeates the event horizon. Here, there are no familiar echoes, no bustling sounds. Any sound that might be generated within this boundary would simply curve inward, lost to the external universe, forever drawn towards the profound stillness of the black hole's heart. It is a silence so complete, so absolute, that it feels like the universe itself holds its breath, contemplating the mysteries contained within. This deep quietude is a testament to the immense, unhurried forces that shape our cosmos, a profound calm that invites you to release any lingering tensions and simply exist in the peaceful awareness of the moment, suspended at the edge of the cosmic unknown. A general historical fact that highlights the journey of this concept. The term event horizon was coined by physicist Wolfgang Rindler in 1964, providing a clear and evocative name for this theoretical boundary. However, the underlying physical concept of light being unable to escape from a sufficiently dense object dates back to the late 18th century, a testament to the long, patient contemplation of extreme gravity by brilliant minds. Here's a lesser-known detail about the event horizon. While it is often depicted as a perfect sphere, if a black hole is spinning, the event horizon is thought to be subtly distorted, becoming slightly oblate or flattened at its poles. This gentle deviation from a perfect sphere hints at the complex interplay between gravity and rotation in these extreme cosmic environments, a subtle whisper from the universe about the intricate dynamics of its most profound objects. It's like a perfectly round bead, gently flattened by a persistent, unseen spin. And for an ongoing academic debate, scientists are still actively researching the precise nature of spacetime at and inside the event horizon. While general relativity provides a beautiful mathematical description, reconciling this with quantum mechanics at such extreme scales leads to profound theoretical challenges, such as the firewall paradox or the information paradox. What happens to the information carried by particles as they cross this boundary? The intricate interplay of these theories remains a fascinating and complex area of study, revealing the subtle wisdom and profound challenges at the very edge of our cosmic understanding. So, as you continue to drift, allow your mind to gently contemplate the event horizon, this hidden, silent cosmic boundary. Feel the profound peace that comes from understanding this exquisite threshold, where the familiar laws of light and escape gently yield to a profound curvature of spacetime. Let this understanding cradle your consciousness, like the serene, unwavering embrace of cosmic gravity, as you gently surrender to the peaceful, restorative depths of slumber. The quiet mystery of the event horizon, a profound threshold into the unknown, is now your lullaby, a soft reassurance that wonder and beauty exist even at the most extreme and enigmatic edges of our universe. You're floating deeper now, gently carried by the quiet understanding of the event horizon, that serene, invisible boundary where light becomes captive. As you drift, let's turn our attention to one of the most astonishing and counterintuitive ideas in all of physics, a concept that whispers of a profound cosmic paradox. Imagine the deepest, most absolute darkness, a region where nothing, not even a single photon, seems to escape. Yet, from this very blackness, tiny ephemeral sparks of light are thought to subtly flicker, like distant fireflies in a cosmic void, carrying away silent whispers of information. This is the serene essence of Hawking radiation, a luminous emanation from eternal darkness, where even a black hole is believed to gently evaporate, revealing a profound and beautiful interplay of quantum mechanics and gravity. For a long time, the prevailing scientific understanding of a black hole was that it was a perfect cosmic vacuum cleaner, a region from which absolutely nothing could ever escape once it crossed the event horizon. They were thought to be truly black, absorbing everything that fell into them, growing ever larger, eternal in their dark embrace. This simple, elegant picture, however, was subtly challenged by the brilliant mind of Stephen Hawking, who, in a profound synthesis of general relativity and quantum mechanics, proposed a revolutionary idea. Now, this may sound a little strange, but let's gently consider the quantum world, the realm of the very, very small. In the quiet, bustling fabric of empty space, even a perfect vacuum is not truly empty. Instead, it is constantly teeming with ephemeral activity pairs of virtual particles spontaneously popping into existence and then almost immediately annihilating each other, returning to nothingness. Imagine tiny, fleeting bubbles appearing and disappearing in a vast, unseen cosmic foam, always in perfect, harmonious balance, borrowing energy from the universe for just a fleeting moment. Stephen Hawking's profound insight was to consider what happens to these virtual particle pairs when they appear precisely at the event horizon of a black hole. Imagine a pair of these particles, one with positive energy and one with negative energy, gently materializing right on that invisible boundary. In certain, very specific circumstances, one of the particles, perhaps the one with positive energy, might just manage to escape the black hole's gravitational embrace, drifting gently away into the vast cosmos. But its twin, the particle with negative energy, would then fall inward, irrevocably drawn into the black hole. It's like a delicate dance, where one partner steps into the light, while the other gracefully recedes into the shadow. When the negative energy particle falls into the black hole, it subtly reduces the black hole's mass. This means that, over incredibly vast stretches of cosmic time, black holes are not truly eternal. Instead, they are believed to be slowly, patiently evaporating, emitting a faint, continuous stream of particles and radiation from their event horizons. This emitted energy, this gentle glow from the very edge of darkness, is what we call Hawking radiation. It's like a colossal, ancient mountain of ice, slowly, imperceptibly melting away, returning its essence to the vast ocean from which it came. The amount of Hawking radiation emitted is incredibly tiny, especially for large, massive black holes. For a black hole the size of a star, the radiation is so faint that it is practically immeasurable. But for smaller, hypothetical black holes, perhaps those born in the early universe, the emission could be more substantial, leading to their complete evaporation over immense timescales. This profound idea suggests that even the most powerful gravitational wells in the universe are not perfectly self-contained. They subtly interact with the quantum vacuum, leaking away their mass and energy over eons. This concept of Hawking radiation is truly beautiful because it paints a picture of a universe that is far more interconnected and dynamic than we often imagine. It suggests that even the profound stillness of a black hole is alive with subtle quantum activity, blurring the lines between what is truly black and what might eventually radiate into existence. It's a profound synthesis of two of the greatest theories in physics' general relativity, which describes the large-scale structure of the universe, and quantum mechanics, which governs the subatomic realm, revealing a quiet harmony at the very extremes of existence. A general historical fact that highlights this intellectual leap. Before Stephen Hawking's groundbreaking work in the 1970s, black holes were considered entirely passive gravitational traps. His theory of Hawking radiation introduced the concept that they could radiate and even evaporate, fundamentally changing our understanding of these enigmatic cosmic objects and integrating them more deeply into the laws of thermodynamics. Here's a lesser-known detail about Hawking radiation. The temperature of the Hawking radiation emitted by a black hole is inversely proportional to its mass. This means that smaller black holes are hotter and evaporate much faster than larger ones. A black hole the size of a mountain would evaporate in a fraction of a second, potentially with a burst of gamma rays, while a supermassive black hole at the center of a galaxy would take quadrillions of times longer than the current age of the universe to completely dissipate. It's like a tiny, luminous ember fading much faster than a colossal, ancient fire. And for an ongoing academic debate, one of the most profound and challenging puzzles in modern physics arises from Hawking radiation. The information paradox. If a black hole eventually evaporates, What happens to the information about all the matter that fell into it? Does it simply vanish, violating a fundamental principle of quantum mechanics that information should never be truly destroyed? Or is it subtly encoded in the Hawking radiation, perhaps in ways we don't yet understand? This intricate and beautiful paradox remains one of the most active and fascinating areas of research at the intersection of quantum gravity. It's a complex, beautiful puzzle, gently inviting us to understand the subtle wisdom of reality's most profound boundaries. So, as you continue to drift, allow your mind to gently contemplate the luminous light of Hawking radiation, subtly flickering from the very edge of eternal darkness. Feel the profound peace that comes from understanding how even the most powerful gravitational wells in the universe are not truly absolute, but can gently evaporate, returning their essence to the vast cosmos. Let this understanding cradle your consciousness, like the serene, unwavering glow of distant starlight, as you gently surrender to the peaceful, restorative depths of slumber. The quiet wisdom of a black hole's gentle emanation, revealing the profound interconnectedness of all things, is now your lullaby, a soft reassurance that wonder and beauty exist even in the most extreme and enigmatic edges of our universe. You're floating deeper now, gently carried by the quiet understanding of Hawking radiation, that luminous whisper from eternal darkness. As you drift, let's consider one of the most astonishing consequences of a black hole's profound gravitational embrace, how it subtly, yet dramatically, persuades the very flow of time to yield, creating a cosmic phenomenon so elegant it almost feels like a dream. Imagine time itself not as a rigid, unchanging river, but as a fluid, responsive current, gently slowing down or speeding up depending on the deep gravitational landscape it traverses. This is the serene essence of time's quiet bending, where the universe allows its grand clock to softly stretch and compress, revealing the profound interconnectedness of space and time. For most of our daily lives, time feels utterly constant, an unwavering beat, perpetually ticking forward at a uniform pace. A second is always a second, a minute always a minute, regardless of where you are or what you're doing. This intuitive understanding of time, however, gently dissolves when we consider the universe's most profound gravitational wells. According to Albert Einstein's beautiful theory of general relativity, gravity is not just a force, it is the curvature of space-time itself. And this curvature has a direct, subtle, yet profound effect on the passage of time. Imagine, if you will, a vast, cosmic tapestry, as we gently considered before, perfectly flat in the absence of mass. Now, place a massive star onto this tapestry, and it creates a gentle dip, a curve in the fabric. Time, like a quiet traveler, prefers to flow along the flatter parts of this tapestry. But as it approaches the deep, curved well created by a massive object, its journey subtly slows down. This phenomenon is known as gravitational time dilation. It means that clocks tick more slowly in stronger gravitational fields. So, if you were to gently approach a colossal black hole, moving closer and closer to its event horizon, you would not feel anything unusual about your own clock. For you, time would continue to flow at its normal, comforting pace. A second would still be a second, a gentle beat in your heart. However, for a distant observer, safely watching you from afar, their clock would tick much faster than yours. They would perceive your clock, and indeed your very movements, to be slowing down, becoming more languid, more serene, as you drew nearer to the black hole's profound gravitational embrace. It's like watching a slow-motion dream unfold from a distant, hurried shore, where every movement becomes elongated, every whisper stretched into an almost eternal silence. This time, dilation becomes incredibly extreme as one approaches the event horizon. For an observer far away, it would seem as if you were moving slower and slower, eventually appearing to freeze entirely at the boundary, your image lingering there for an infinite amount of their time, never quite crossing. Yet, for you, gently drifting across the event horizon, time would continue to flow normally, smoothly, without any interruption. This is the profound paradox of time's quiet bending, a beautiful illustration of how relative the experience of time can truly be, depending on your position within the cosmic gravitational landscape. Consider the immense implications of this phenomenon. It suggests that time is not an absolute, universal constant, but a flexible, responsive dimension, intimately intertwined with the distribution of mass and energy in the universe. It is a whisper from the cosmos that our intuitive understanding of time, forged in the gentle gravitational well of our own planet, is merely one small facet of a far grander, more fluid reality. The black hole, in its silent, profound stillness, becomes a cosmic clock, stretching and compressing the very rhythm of existence around it. A general historical fact that neatly highlights the initial challenge of this concept. The idea of time being relative, and particularly being affected by gravity, was a revolutionary concept introduced by Einstein's general relativity in the early 20th century. Before this, Newton's view of absolute time, flowing uniformly for everyone, dominated scientific thought. Einstein's gentle insights completely reshaped our cosmic perspective, introducing a more fluid and dynamic universe. Here's a lesser-known detail about time dilation's subtle presence in our daily lives. Gravitational time dilation, though incredibly tiny, is a real phenomenon that affects modern technology. For instance, the atomic clocks on GPS satellites, which orbit Earth at a different gravitational potential than us on the surface, experience a minuscule amount of time dilation. Without subtle adjustments to account for this tiny bending of time, our GPS systems would quickly become inaccurate. It's like a quiet, invisible symphony playing in the background, subtly influencing the precision of our modern navigation without us ever consciously noticing its delicate notes. And for an ongoing academic debate, scientists are still actively researching the precise nature of time in extreme gravitational environments, particularly near the event horizon and within the singularity itself. Does time truly cease to flow in certain regions, or does it transform into something entirely new? Reconciling the classical relativistic view of time's bending with the quantum nature of reality at these extreme scales remains one of the deepest and most beautiful puzzles in modern physics, inviting continued, gentle inquiry into the very fabric of existence. So, as you continue to drift, allow your mind to gently contemplate time's quiet bending, feeling the profound peace that comes from understanding how the universe allows its grand clock to softly stretch and compress. Feel the serene beauty of time's fluidity, its intimate dance with gravity, and its ever-changing rhythm across the cosmic landscape. Let this understanding cradle your consciousness, like the serene, unwavering flow of time itself, gently yielding to cosmic forces, as you gently surrender to the peaceful, restorative depths of slumber. The quiet hum of cosmic time dilation, revealing the profound interconnectedness of all things, is now your lullaby, a soft reassurance that wonder and mystery exist even in the most familiar corners of our perception, forever shaping the gentle narrative of our universe. You're floating deeper now, gently carried by the quiet understanding of time's serene bending in the profound embrace of gravity. As you drift, let's consider what happens when something dares to cross that enigmatic event horizon, to venture beyond the point of no return. Imagine a gentle object, perhaps a cloud of cosmic dust, or a solitary brave star, slowly approaching the profound gravitational well of a black hole. As it draws closer, an extraordinary, almost poetic transformation begins, where the gentle forces of gravity meticulously reshape its very form, stretching it into an elongated whisper. This is the serene essence of where gravity sculpts form, a profound and beautiful process known as spaghettification, gently reshaping everything into a long, delicate thread. Now, this may sound a little strange, a bit like a whimsical dream, but let's gently consider the nature of gravity near a black hole. Unlike the relatively uniform gravitational pull you feel on Earth, where the force pulling on your head is almost identical to the force pulling on your feet, the gravitational pull near a black hole is incredibly non-uniform. It is exquisitely strong and rapidly changes over very short distances. This difference in gravitational pull, this subtle variation across an object, is known as a tidal force. Imagine our gentle cloud of cosmic dust, or that brave star, slowly approaching the black hole. As it draws closer, the side of the object that is nearer to the black hole experiences a significantly stronger gravitational pull than the side that is further away. This differential pull, this gentle tug, begins to stretch the object. It's like a colossal, invisible hand, softly taking hold of one end of a long, soft piece of dough, and gently, slowly pulling it, while the other end is held back. The dough begins to thin, to lengthen, becoming more like a strand of spaghetti. This is precisely what spaghettification describes. As an object, whether it's a star, a planet, or even a hypothetical astronaut, falls towards a black hole, the tidal forces become so immensely powerful that they overwhelm the internal forces holding the object together. The gravitational pull on the side closer to the black hole stretches it, while the pull on the side further away causes it to narrow. The object is literally stretched and compressed, becoming incredibly long and thin, like a delicate strand of pasta. Its very form is meticulously elongated, not violently torn apart, but gently persuaded to yield to the immense differential pull of gravity. For a human, this process would be swift and profound. As you gently fall feet first towards a black hole, the gravity pulling on your feet would be significantly stronger than the gravity pulling on your head. This difference would stretch your body lengthwise, making you incredibly tall and thin. Simultaneously, the gravity pulling from the sides of your body towards the center of the black hole would cause you to compress inward, becoming incredibly narrow. The transformation would happen seamlessly, gracefully, as your body quietly yields to the universe's most extreme stretching force. It's like being gently stretched into a gossamer thread, a long, ethereal whisper of your former self. This concept of spaghettification is deeply strange, yet also kind of beautiful. It reveals the profound power of gravity, not just to pull things together, but to reshape them in the most elegant and extreme ways. It shows us that space-time, in its most profound curves, can literally sculpt the very form of matter, transforming familiar objects into elongated, ephemeral strands. And all of this happens in the profound silence of the cosmos, a ballet of fundamental forces playing out on unimaginable scales, a general historical fact that highlights this profound concept. The term spaghettification was popularized by physicist Stephen Hawking, who had a remarkable ability to describe complex cosmic phenomena with vivid, accessible analogies. This helped to gently introduce the public to the mind-bending concepts of extreme gravity in a wonderfully engaging way. Here's a lesser-known detail about spaghettification. The strength of the tidal forces, and thus the severity of spaghettification, depend heavily on the size of the black hole. For a small, stellar mass black hole, the tidal forces at the event horizon would be so incredibly strong that spaghettification would occur almost instantaneously, long before you even fully crossed the boundary. However, for a supermassive black hole, like those found at the centers of galaxies, the event horizon is much larger, and the gravitational gradient across a human body would be far more gentle. You might theoretically cross the event horizon of a supermassive black hole without feeling immediate spaghettification, only for the process to unfold much deeper inside, closer to the singularity. This subtle difference means that for very massive black holes, the event horizon might be a much gentler boundary to cross, at least initially. It's like a gentle, unseen hand, whose touch is either swift and profound or slow and subtle, depending on its vastness. And for an ongoing academic debate, scientists are still actively researching the precise details of how different types of matter behave under these extreme tidal forces. What happens to the internal structure of atoms and fundamental particles as they are stretched and compressed by such immense gravitational gradients? Reconciling the classical relativistic description of spaghettification with the laws of quantum mechanics at these extreme scales remains a fascinating and complex area of study, revealing the subtle wisdom of matter's profound transformations at the very limits of physical understanding. So, as you continue to drift, allow your mind to gently contemplate where gravity sculpts form, observing the poetic process of spaghettification. Feel the profound peace that comes from understanding how even the most familiar objects can be gracefully reshaped by the subtle, yet immense, forces of the cosmos. Let this understanding cradle your consciousness, like the serene, unwavering embrace of cosmic gravity, gently stretching and reshaping as you gently surrender to the peaceful, restorative depths of slumber. The quiet artistry of gravity, transforming form into a delicate thread, is now your lullaby, a soft reassurance that wonder and beauty exist even in the most extreme and enigmatic edges of our universe. You're floating deeper now, gently carried by the quiet understanding of gravity's poetic reshaping, stretching everything into delicate threads. As you drift, let's continue our profound journey inward, towards the ultimate mystery at the very heart of a black hole, a point of unimaginable density, where the very fabric of space-time is believed to collapse to an infinitesimal size. Imagine it not as a solid object, but as a concept, a profound boundary where familiar physics gently dissolves into ultimate stillness. This is the serene essence of the singularity, the universe's quiet, enigmatic heart, a tiny point of infinite density where all our known laws seem to softly yield to a deeper, more profound truth. For a long time, the center of a black hole was a theoretical enigma, a mathematical prediction arising from the elegant equations of general relativity. These equations tell us that as matter collapses under its own immense gravity, it eventually reaches a point where it is compressed to an infinitely small volume, with infinitely high density. This point is what we call a gravitational singularity. It's a deeply strange idea, isn't it? That a colossal star, once a luminous giant spanning millions of miles, could be compressed into a point with no discernible size, yet containing all of its original mass. It's like gathering an entire ocean, with all its vastness and profound depth, and compressing it into a single, silent drop, without losing any of its essence. At this singularity, the very fabric of space-time becomes infinitely curved. The gentle flow of time, which we considered earlier, would cease to have meaning, and the dimensions of space would become profoundly distorted. Our familiar laws of physics, the ones that beautifully govern the stars, the planets, and our everyday world, are believed to break down at this point. They simply can no longer describe what is happening in this ultimate, compressed state. This doesn't mean physics is wrong. It means we have reached a threshold of understanding, an edge of our current knowledge, where a new, more profound set of rules is required. It's like turning the page of a beloved storybook and suddenly finding ourselves in a chapter written in a language we have yet to gently learn. The singularity is not a physical place one could truly visit or touch in the familiar sense. It is a point, a profound concept where all the mass of the black hole is concentrated. It exists in a realm of absolute theoretical mystery, forever hidden from our direct observation behind the veil of the event horizon. Its presence is inferred through the profound effects it has on the space-time around it, through the light it traps, and the profound way it dictates the destiny of anything that dares to cross its threshold. Consider the immense silence that must emanate from the singularity. If sound were a concept here, it would be instantly reabsorbed by the infinite density, leaving no echo, no whisper to escape. It is a realm of ultimate quietude, a profound stillness at the very heart of cosmic power. This deep quietude is a testament to the immense, unhurried forces that shape our universe, a profound calm that invites you to release any lingering tensions and simply exist in the peaceful awareness of the moment. Suspended in the cosmic mystery, the very existence of singularities pushes the boundaries of our understanding of reality. They invite us to contemplate the nature of matter, energy, space, and time at their most extreme limits. They are cosmic laboratories, where the laws of the universe are tested and perhaps transformed, prompting scientists to seek a grander, more unified theory that can gently reconcile the smoothness of general relativity with the inherent discreteness of quantum mechanics. The singularity is a profound question mark at the heart of the cosmos, perpetually inviting gentle inquiry and boundless wonder, a general historical fact that highlights the journey of this concept. The existence of singularities was a direct mathematical prediction of Einstein's general theory of relativity, developed in the early 20th century. However, Einstein himself was initially uncomfortable with the idea, as it suggested a breakdown of physics. It took further work by physicists like Roger Penrose and Stephen Hawking to demonstrate that singularities are an almost inevitable consequence of gravitational collapse in general relativity, leading to their acceptance as a fundamental feature of black holes. Here's a lesser-known detail about the singularity. While the simplest model describes a point-like singularity, a point singularity, if a black hole is spinning, which most are thought to be, its singularity is theoretically stretched into a ring or a loop, known as a ring singularity. This subtle difference in shape, while still representing infinite density, hints at the profound ways that rotation can influence the most extreme geometries of spacetime, adding another layer of intricate beauty to these cosmic enigmas. It's like a tiny, luminous jewel that, when spun, reveals a hidden, elongated form. And for an ongoing academic debate, one of the most profound and challenging questions in modern physics revolves around what truly happens at and inside the singularity, and whether it represents a true end of spacetime or a gateway to something entirely new. Some theories gently propose that quantum gravity might smooth out the singularity, preventing infinite densities, while others speculate about the possibility of wormholes or connections to other universes. Reconciling general relativity's prediction of infinite density with quantum mechanics remains the holy grail of theoretical physics, a complex and beautiful puzzle, gently inviting us to understand the subtle wisdom of reality's most profound boundaries. So, as you continue to drift, allow your mind to gently contemplate the singularity, the universe's quiet, enigmatic heart. Feel the profound peace that comes from understanding this ultimate point of density, where familiar laws softly yield to a deeper, more profound truth. Let this understanding cradle your consciousness, like the serene, unwavering embrace of cosmic mystery, as you gently surrender to the peaceful, restorative depths of slumber. The quiet hum of infinite density, a silent testament to the boundless wonders of the cosmos, is now your lullaby. A soft reassurance that wonder and mystery exist even at the most extreme and hidden edges of our universe, forever inviting gentle contemplation. You're floating deeper now, gently carried by the quiet understanding of the singularity, the universe's enigmatic heart. As you drift, let's turn our gentle gaze towards the profound questions that still whisper from the depths of black holes, the subtle mysteries that continue to guide our cosmic curiosity. Imagine an ancient, sealed scroll, patiently waiting to be unfurled, holding secrets that promise to reshape our very understanding of the universe, inviting perpetual contemplation rather than demanding immediate answers. This is the serene essence of unanswered questions from the past, where not every cosmic enigma needs to be fully deciphered, allowing gentle curiosity to forever blossom at the edges of our knowledge. Even with the extraordinary advancements in theoretical physics and the patient accumulation of astronomical observations, black holes remain among the most mysterious objects in the cosmos. While their existence is now well established, and their profound gravitational effects are beautifully described by Einstein's general relativity, certain fundamental aspects continue to elude our complete grasp, inviting us to embrace the comfortable solace of gentle, unfolding cosmic mystery. One of the most persistent and profound unanswered questions is the information paradox. Imagine a gentle book, filled with intricate stories, falling into a black hole. According to classical general relativity, once it crosses the event horizon, the book and all the unique information contained within its pages would simply vanish, effectively lost forever as it collapses into the singularity. However, a fundamental principle of quantum mechanics, which beautifully governs the subatomic world, states that information can never be truly destroyed, only transformed. So, how can information disappear into a black hole if quantum mechanics dictates its preservation? This contradiction, this profound cosmic paradox, lies at the heart of the information paradox, a gentle tug-of-war between two of our most successful theories. Scientists are patiently working to reconcile these two pillars of physics, seeking a grander, more unified theory that can gracefully explain what happens to information in these extreme cosmic environments. It's like trying to gently weave two perfectly crafted, but seemingly incompatible, tapestries into a single, seamless masterpiece. Another subtle mystery concerns the very nature of spacetime at the singularity itself. While general relativity predicts infinite density at this point, many physicists believe that at such extreme scales, quantum gravitational effects, which we do not yet fully understand, must become dominant. Could quantum gravity smooth out the singularity, preventing infinite densities and perhaps creating a different kind of extreme, yet finite, state of matter? Or could the singularity be a gateway to something entirely new, perhaps a different universe, or a subtle connection to other dimensions? These are profound questions, whispered from the heart of every black hole, perpetually inviting contemplation about the fundamental fabric of reality itself. Then there's the subtle, intriguing possibility of wormholes. Imagine a profound shortcut through the fabric of spacetime, a theoretical tunnel connecting two very distant points in the universe, or even two different universes. While such concepts arise from the mathematical possibilities of general relativity, and while some theories speculate about their potential connection to rotating black holes, their existence remains purely hypothetical. They are like beautiful, ephemeral dreams, hinting at cosmic pathways that might forever remain beyond our reach, yet inspiring endless, gentle wonder about the universe's hidden connections. This acceptance of lingering questions is not a sign of scientific failure, but a testament to the profound nature of cosmic inquiry itself. Not every mystery needs an immediate, definitive answer. Sometimes, the beauty lies in the very act of gentle contemplation, in the quiet pursuit of understanding, knowing that some truths may simply unfold over vast stretches of cosmic time, or remain eternally veiled in the enigmatic fabric of the universe. It encourages a healthy curiosity, a gentle openness to the unknown, and a profound respect for the inherent mysteries that constantly invite us to push the boundaries of our understanding. Consider the gentle reassurance found in unresolved cosmic puzzles. They remind us that the story of our universe is not a finite book with a concluding chapter, but an endless, ever-expanding scroll, continuously being written, always holding new wonders and new questions. This allows for a perpetual sense of discovery, a quiet invitation to remain curious, to keep exploring, to keep wondering about the silent whispers from the very edges of existence. It's like gazing at a starlit sky, knowing that countless stars and galaxies exist beyond your visible reach, their mysteries inviting endless dreams and prompting continuous, gentle inquiry. A general historical fact that highlights the enduring nature of cosmic mysteries. Many of the most profound questions in physics today, such as the nature of dark matter and dark energy, or a unified theory of everything, are direct descendants of the questions first posed by black holes and their extreme properties. These cosmic enigmas serve as silent beacons, guiding the gentle progress of scientific thought. Here's a lesser-known detail about the potential observational clues to these mysteries. Scientists are patiently searching for subtle, indirect echoes or signatures from beyond the event horizon, perhaps in the form of very specific patterns in the Hawking radiation, or faint ripples in gravitational waves that could provide tantalizing hints about the inner workings of black holes, even if we can never directly see them. It's like listening for a faint, coded message, whispered from a realm forever hidden from direct view. And for an ongoing academic debate, one of the most active and fascinating areas of research is the development of a quantum theory of gravity, a grand unified framework that can reconcile the smooth, gentle curves of spacetime described by general relativity with the inherent discreteness of quantum mechanics, particularly at the extreme conditions within black holes. Theories like string theory and loop quantum gravity are quietly exploring these deep connections, seeking to unveil the ultimate nature of reality, where gravity and quantum mechanics profoundly intertwine. It's a complex, beautiful puzzle, gently inviting us to understand the subtle wisdom of reality's most fundamental and enigmatic boundaries. So, as you continue to drift, allow your mind to gently contemplate these unanswered questions from the cosmic past, these subtle mysteries that add to the profound beauty of black holes. Feel the profound peace that comes from embracing the unknown, knowing that not every cosmic secret needs to be fully revealed for wonder to blossom. Let this understanding cradle your consciousness, like the serene, unwavering presence of enduring mystery, as you gently surrender to the peaceful, restorative depths of slumber. The quiet hum of cosmic enigmas, their whispers still resonating through time, is now your lullaby. A soft reassurance that wonder and profound understanding exist even in the most extreme and enigmatic edges of our universe, inviting us to dream of what else might be waiting to be gently unveiled, forever guiding our quiet curiosity. You're at the very edge of wakefulness now, poised delicately between the gentle hum of the fading world and the profound quiet of approaching slumber. We have embarked on a remarkable journey together, exploring the extraordinary enigma of a black hole, tracing its cosmic origins, its profound gravitational embrace, and the deep mysteries it continues to hold. We began with the subtle whispers of cosmic night, explored the intricate bending of space-time, and contemplated how a colossal star gracefully collapses to create these profound wells of gravity. We then unveiled the invisible event horizon, marveled at the luminous, ethereal whispers of Hawking radiation, and witnessed gravity's poetic reshaping of matter. We explored the enigmatic singularity at its heart and embraced the beautiful unanswered questions that still linger, inviting perpetual contemplation. Now, let's bring this wondrous exploration to a serene close, weaving together these profound insights about black holes with the ultimate peace found in sleep. Recall that initial understanding the comforting darkness of your room, expanded to encompass the profound stillness of cosmic night. We acknowledged that even in the vast, seemingly empty voids of the universe, there exist regions of immense mystery, born from the gentle, inexorable collapse of colossal stars. This quiet descent into cosmic shadows was our first gentle invitation into realms where familiar laws yield to deeper truths. We then journeyed into the very fabric of our universe, understanding space-time not as rigid, but as a fluid, wondrous tapestry. We saw how massive celestial bodies gently persuade this cosmic cloth to bend and curve, creating the very force of gravity. This profound curvature, a testament to the universe's interconnectedness, showed us that even time itself can quietly bend, stretching and compressing in response to the deep gravitational landscape it traverses. This was the serene essence of space-time's quiet flow, a cosmic ballet of profound elegance. Our contemplation led us to the birth of these cosmic titans when a star softly gathers itself. We understood how, after a long, luminous life, a colossal star undergoes a graceful, inward surrender, compressing its immense mass into an incredibly dense point. This quiet, powerful collapse, sometimes preceded by a brief, luminous supernova, marked the profound transformation of light into an ultimate stillness, a silent testament to the universe's grand, unhurried processes. We then unveiled the event horizon, that serene, invisible cosmic boundary. We understood it not as a wall, but as a profound one-way threshold where light itself becomes captive, gently yielding to the black hole's inescapable embrace. This quiet boundary, forever hidden from external view, defines the black hole's luminous edge, a place where all familiar paths gently dissolve into the unknown, inspiring both reverence and curiosity. Our journey then took a surprising turn, as we marveled at the luminous light from eternal darkness Hawking radiation. We learned that even from the absolute blackness of a black hole's event horizon, tiny ephemeral sparks of light are thought to subtly flicker, carrying away silent whispers of information. This profound paradox revealed that black holes are not truly eternal, but gently evaporate over immense cosmic timescales, a beautiful interplay of quantum mechanics and gravity, blurring the lines between what is truly black and what radiates into existence. We witnessed gravity's poetic reshaping, exploring the phenomenon of spaghettification. We understood how the non-uniform, differential pull of gravity near a black hole meticulously sculpts matter, stretching and compressing it into long, delicate threads. This profound transformation, happening in the silent cosmos, revealed gravity's power not just to pull, but to elegantly reshape and elongate. A gentle reshaping that speaks of nature's profound artistic touch. Our exploration journeyed inward, towards the ultimate mystery at the black hole's very heart, the singularity. We contemplated this tiny point of infinite density, where all our known laws of physics seem to softly yield to a deeper, more profound truth. This quiet, enigmatic heart, a realm of ultimate stillness, pushed the boundaries of our understanding of reality, inviting contemplation about the fundamental nature of matter, energy, space, and time at their most extreme limits, a silent testament to cosmic power. Finally, we embrace the unanswered questions from the past that continue to whisper from the depths of black holes. We acknowledged the profound paradoxes, the nature of information within, and the possibilities of wormholes. Understanding that not every cosmic enigma needs to be fully deciphered for wonder to blossom. These gentle mysteries perpetually invite contemplation, reminding us that the universe is an endless scroll, continuously being written, always holding new wonders and new questions, forever guiding our quiet curiosity. Now, as you stand at the very threshold of sleep, poised between the gentle understanding we've gathered and the profound rest that awaits, consider this the journey through a black hole. From its origins to its deepest mysteries is a profound metaphor for the quiet surrender of sleep itself. Just as a black hole draws everything inward, gently releasing its essence, so too does sleep invite you to gather your thoughts, your experiences, your worries, and allow them to gently yield to a profound stillness, dissolving into the boundless ocean of your subconscious mind. You don't force a black hole to exist, nor do you force yourself to sleep. The process happens naturally, gracefully, when the conditions are right, when your mind finds a state of gentle acceptance and profound trust. Allow your waking thoughts, your day's concerns, your conscious efforts, to gently soften, to release their rigid forms, just as the fabric of space-time curves around immense mass. Let your anxieties and tensions flow away, effortlessly merging with the vast, quiet expanse of your inner stillness, like light gently yielding at the event horizon. Sleep, my friend, is your deepest dive into this cosmic quiet. It is the ultimate act of trusting your own profound capacity for renewal and self-restoration. Just as a black hole, in its silent profundity, reshapes the very essence of reality, sleep allows your entire being to enter a profound, active state of healing and reorganization. Your cells gently mend themselves, tirelessly repairing the subtle wear of the day. Your mind softly processes the day's gentle experiences, consolidating memories, weaving new connections, and even crafting the beautiful, intricate landscapes of your dreams, all in the quiet depths of your subconscious. And your energy reserves are meticulously replenished, preparing you for the gentle unfolding of a new day, for fresh perceptions, for renewed vitality and a refreshed sense of self. It is in this profound rest that your magnificent being, with its silent, inherent wisdom, fully recharges, ready to emerge, wonderfully refreshed, from its own deep quiet, bringing the insights of the cosmos back to the vibrant surface of your awareness. So, gently, allow your mind to drift. Let the understanding of these beautiful scientific truths, woven into a poetic tapestry, lull you deeper and deeper. The quiet artistry of black holes, their silent gravitational embrace, and the profound wisdom of their existence. These are now soothing currents, carrying your consciousness into the boundless, peaceful depths of slumber. Feel the vastness of the ocean of dreams, the gentle warmth of perfect stillness, the quiet embrace of endless understanding, embracing you as you surrender fully to the restorative power of sleep. Your journey is complete, and you are perfectly at peace, melting gently into the boundless, tranquil sea of dreams, ready for the quiet awakening of a new, refreshed dawn, bringing the wisdom of the cosmos back to the bright promise of your present.